Hello, welcome to another mouse video. We're now going to talk about bivariate data. So, if you haven't heard already, bivariate meaning two, variate meaning variable. So we're going to consider two different things here. So, on our survey, let's take the idea of height and weight. So we're going to be linking height and weight in our survey here. So our data is going to come not in two forms. So you might be used to just getting height and height. You would have just got your heights being, 170, 171, 173, etc. But here for bivariate, I'm actually going to be linking two things. I'm going to have my height and weight, so I might get the form height and weight, and they will go together in people. So my first data point might be a height of 170 and a weight of 70 kilos. My second person might have a height of, say, 173 and a weight of 78 kilos. My next person might have a height of 175 and a weight of 82 kilos. You get the idea. What we can do with our bivariate data is we can now go and graph these. Okay, so we can set it up as a set of coordinates. So 170, so in terms of doing that, set your axes up. The axes I'm going to have, well, my x-axis on my data here is my heights, and my y-axis is my weights. Otherwise, it's the same as plotting them, exactly the same as you would plot any normal coordinates, and this is called a scatter plot. So just putting a few data points in here. If I have 170, my lowest weight was 70, my first data point would go there. Then next, let's go 171, 172, 173, 174, 175. 173, 1, 2, 3, 78 kilos might be up here. Then next guy, 175, 82, he might be up here. So what the whole point of this is going to be looking at connecting my data somehow. Is there some pattern between the two? Okay. So that's kind of the point. This is called a scatter plot, by the way. And I would certainly encourage you to draw your graph on a computer if you can. So that's why we're in full screen today, which is nice. What I've done, I've taken some data, and I've taken a survey that I did a couple of years ago with some of my students, and we'll just take some data. So here, students' heights versus students' weights. So just go through, check for any junk data. I've already deleted a few scores here. I'm just looking through right even now. 21, 21 obviously is rubbish. Everything else seems realistic-ish. I mean, 45 is a little on the lower end, I would have thought, but give it a go. So what we can do is select the data, just copy all that. Go to Desmos, good old Desmos, our old graphing friend. Wait a second, let to load. Then just dump our data in, so copying and pasting that across. In terms of axes, label your axes before you do any real work. So the x-axis, probably tell here's the height. If you are in doubt, go back to the question, height, then weight. So just label them, come across here, x-axis is height, our y-axis is weight. Okay, so you can see those two illustrated there. And it probably doesn't strike you as massively surprising, but there looks like a connection in there. So it looks like height and weight of students in this example are linked. And that's kind of the point of bivariate data. So trying to find that connection if you can. Okay. Outliers will be unique, unusual scores. So if I do want to throw an outlier in here, just so you guys get the point, if I threw an outlier in here, let's just get, Shaq rolled up to math class. I don't know how tall he is. Let's say it's 220. And let's say Shaq's weight in kilos is 150. So that's Shaq there, by the way. Obviously well out an outlier in our class. Okay, that's bivariate data in a nutshell. I think it's more interesting than single variable because you do get that link. You can go and study how close things are connected, which is nice. Thanks for watching, and all the best doing some questions examples for yourself.